Okay, in 6.3, this is part one video. We're going to be talking about trigonometric functions of angles. I'll be looking at a few things like I can find the other 5 trig functions given one of them. I can use a reference angle. I call that theta prime to find the exact value of a trig function. Then I can express one trigonometric function in terms of another. We'll be doing that in the part 2 video. We're not going to be looking at the area of a triangle. Okay, so definition of the trig functions. It says let theta be an angle in standard position. Remember that standard position is always between the nearest x-axis and the terminal side being here. Then it says let p of x comma y be a point on the terminal side. So this point, we call it x, y, which means that if we talk about values, this distance is x and this distance is y to give us the point x comma y. And then this distance here, we call that the radius r. So we used to say the radius of the unit circle was 1, but now let's say the radius of the circle is not 1. All right, it's now a measure of what r is. Okay, so we'll be finding that. So keeping in tune with SOHCAHTOA, sine is opposite over hypotenuse. So of theta, opposite is y over r. Cosine adjacent over the hypotenuse is x over r. And tangent opposite over adjacent is y over x according to the diagram here. Now keep in mind, sine is still your y, cosine is your x, and tangent is always y over x. It's just that before the radius was 1. Now the radius is not 1, so we put y over r. We put y over r here, x over r, and then still the tangent is y over x. Let's not forget about the reciprocals. The cosecant is the reciprocal of the sine, so that's just r over y. Secant is the reciprocal of the cosine, so r over x. And the cotangent is the reciprocal of the tangent. It's just x over y. Okay, here's an example. If the cosecant of theta equals 6 and the secant of theta is less than 0, find the other 5 trig functions of theta. So let's talk about a few things. The cosecant of theta equals 6. First, I like to say, okay, the reciprocal of the cosecant is the sine. So the sine of theta equals, instead of 6 over 1, is 1 over 6. That's going to help me with my diagram. And since the secant of theta is less than 0, that means that the secant, which is like the cosine, is negative. So that puts us in the second quadrant, all right, because cosine is negative. So this direction is negative here, cosine, and the sine is positive, all right? That puts us up here at a point, some random point, but in the second quadrant. Now, if the sine of theta is equal to 1 over 6, according to SOHCAHTOA, the opposite is 1, and the hypotenuse is 6. To find the third side, call it x. We use the Pythagorean theorem. So x squared plus 1 squared equals 6 squared. That will leave us with x squared plus 1 equals 36. Subtract 1 on both sides, x squared equals 35. Then take the square root, and x equals the square root of 35. Keep it in mind, it's going to be negative because it's in the second quadrant, and we already told that the cosine was negative. So in this place here, we say that x is actually equal to negative square root of 35. So now we can find all the other trig functions. The sine of theta equals 1 over 6. The cosine of theta equals adjacent over the hypotenuse. That's 1, or excuse me, that's negative square root of 35 over 6. The tangent of theta is the opposite over the adjacent. So in this case, the diagram says it's 1 over negative square root of 35. Now, if they want you to rationalize that, you'd multiply top and bottom by square root of negative 35. But I'm noticing that your answers on WebAssign are not making you rationalize. We already know the cosecant, right? That was given. So that's why they only are asking for 5. The reciprocal of the cosine is the secant of theta. Flip that over, would be negative 6 over square root 35. If they want you to rationalize that, you'd rationalize it by multiplying top and bottom by square root of 35. And the cotangent of theta is negative square root of 35 over 1, which is just the square root of 35. Let me write that just a little bit better so you can see it better. The square root, negative square root of 35. There you go. Always make sure you take note of which quadrant the answer is going to be in. All right, because that'll take care of your negatives and positives. Okay, now, so reference angles. So it says let theta be an angle in standard position. The reference angle theta, I call it theta prime, associated with theta is an acute angle formed by the terminal side of theta and the x-axis. So you can see all these examples where theta prime is this reference angle. So here, there you go there, here, and here. One thing I want to make note of is that your theta prime is always positive. Always positive. And I think this was picked up in chapter 5, but it's always positive. Now, with that said, let's go look at a few examples. Okay, so it says find the reference angle theta prime. All right, so here's what I like to do. Sometimes I like to just draw it. So the sine of negative 60 takes me clockwise, would be here. And my reference angle would actually be this angle here. And so theta prime would end up being 60 degrees. Remember, it's positive. Cosine of 210 degrees. Well, let's draw it. Halfway around is 180. Halfway around is 180. And if I go 30 more, there is my reference angle right there to be 30 degrees. Negative 495, that becomes a little bit more challenging, but we can handle it. It's negative, so we go halfway, we go all the way around. So all the way around, take us this way. Take us this way. All the way around. That's 360, negative 360. Then what I actually like to do is I like to actually write in the angles. So if I go 90 more, that'll put me at the negative y-axis. So 90 more would be negative 450 right there. And 90 more would put me here at negative 540. And so where's 495? It's somewhere in between here, right there. And that reference angle is this angle drawn right there. Well, from 495 to 540, you can see that that will be 45 degrees. The reference angle is 45 degrees. All right, remember, just be careful not to ever draw your reference angles to the y-axis. I've seen that mistake happen. It's always drawn to the nearest x-axis. So if negative 450 is here, negative 540 is there, negative 495 has to be in the middle of those two. And how much from negative 495 to 540 does it take to get there? 45 degrees. Remember, it's positive. Cotangent, 750 degrees. It will be twice around. Just find the reference angle still. Twice around. It'd be 1 and 2. That's 720. And then 30 more, gives you this angle here, would be 30 degrees. Now that we have our reference angles, now we can go ahead and find the exact value. So the sine of 60 degrees, you can see actually over here on the unit circle, the sine of 60 degrees is our y value. So here it is right here, is actually negative root 3 over 2. Oh boy, hold on one second. There you go. At 30 degrees, so the cosine of 30 degrees, remember it's in the third quadrant. We can do this one of two ways. We can look at it here. We can also look at it here. Back in the day, we used to have kids memorize this. You'll be able to have your notes out. You can go over here and look right here at 30 degrees. the cosine is negative root 3 over 2. So negative root 3 over 2. "45 degrees, again, it's in this quadrant. 45 degrees is right here. And they want the tangent. The tangent is y divided by x. Well, the values are the same, so it would just be 1. Finally, the cotangent of 30 degrees. Remember, it ended up in the first quadrant, so it is actually here. And they want the cotangent, so that's going to be x over y. So you'll take x over y, if you want to show the work, would be root 3 over 2. And since you're dividing by 1/2, I can multiply by the reciprocal. 2 over 1, that cancels. I'm left with root 3. So the cotangent of 750 degrees is equal to root 3. And you can see, so remember, the first number is your reference angle. I found the reference angle. And then from there, I found the value of the sine, cosine, tangent, and cotangent. Be sure to look at part 2 so that you can see the rest of 6.3 to express one trigonometric function in terms of another.